The next part here we're going to look at in section 1.6 are some special nonlinear type of equations, okay? Now, they are nonlinear to begin with, but ultimately they will be linear, okay, once we do some things to them, which would involve the properties of equality. All right, biggest thing I got to point out to you here is you have to be careful. When you do create your new linear equation, it could contain solutions that are actually not solutions of the original equation. And these are called extraneous solutions. You're not going to have any vocabulary on any test or anything like that, but a solution that works based upon what you had to do to the equation to solve it, but does not satisfy the original equation is called an extraneous one, just so you know. All right, so let's go and look at some examples. This first one is going to be real quick. Let's just either look at it and understand the answer is 1/2, or if you don't want to do it that way, which I don't recommend you do it that way, I recommend you use the LCD technique, okay? So we're going to use the multiplication property of equality. We're going to come up with the LCD, which is what? X. So we're going to multiply both sides of this equation by x. And in doing so, we're going to clear out the x's in the denominators. So x times 1 over x is 1. X times, I'm distributing here, x times 2 over x is 2. And then 6 times x is 6x. So we get 3 equals 6x. Dividing both sides by 6, be careful, you're dividing both sides by 6, will lead us to x equaling what? 3 over 6, or 1/2. All right, I mean, you could check that in to the original equation, make sure that it does satisfy it, and it would, okay? 1 divided by 1/2 is 2. 2 divided by 1/2 is 4. 2 plus 4 is 6. Okay. Next one here, we have an algebraic proportion set equal to another algebraic proportion. So this is a ratio of two rational expressions, basically. And what you're really doing is multiplying, again, both sides by the LCD to clear out the 3x plus 2 and the 3x plus 1. Now, with that being said, because it is just a proportion, you don't have any addition or subtraction going on anywhere in this problem, with respect to the rational expressions, you could do what is called cross multiply. Now, cross multiplication is really the same thing as multiplying both sides by the LCD. So this one will look different than the next example because there is a sum of two rational expressions in the next example, where there is not in this one. So again, in this one, because you have a single rational expression set equal to another one, you can just cross multiply, which means the following. This numerator is going to be multiplied by the other expression's denominator. You're going to set that equal to this denominator times the other rational expression's numerator. Again, what you've really done is multiplied both sides by the LCD. If you multiply both sides by 3x plus 2 and 3x plus 1, I guarantee you're going to get this. All right, so once we're here, we have to FOIL. So let's do that. 6x squared. What would this be? Minus 3x and then plus 2x. So minus 3 plus 2 is negative x, and then minus 1. Got to be able to FOIL. Got to be able to FOIL. So the product here would be what? It'd be 6x squared plus 7x, right? 3x plus 4x, 7x, and then plus 2. Okay, note we have a 6x squared on each side. Because that's the case, they are eliminated. In other words, if you were to subtract 6x squared from both sides, you get them to disappear. Now we have a situation where we've seen many times. Let's go ahead and finish this up. So I'm going to subtract 7x from both sides. I'm going to add 1 to both sides. That would allow me to cancel those out. And then negative 1x minus 7x is negative 8x. 2 plus 1 is 3. I would now divide both sides by a negative 8. And therefore, my answer would be negative 3/8. All right, finish with example number 2.